Good morning, everyone. Today we're going to talk about the probability of compound events. So in order to do this, we're going to have to use our sample space lesson that we did the other day to help us create our total outcomes so then we can use it to answer the question. So in this first question, it's talking about Justin, and he's taking to school, and he can take either a bus, a cab, or a train to school, and then he has the same choices coming home. So the first thing I want to do is figure out all the options. I'm going to abbreviate. So going to school, he can do the bus, cab, or the train. And then coming home, he has three options. So again, we want to put those three options off those first three. So here we can do bus, cab, train, bus, cab, train, bus, cab, train. Now when we count those up, we count the last column here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 total choices. And the question is, if Justin randomly chooses his ride in the morning and the evening, what is the probability that he'll use both the bus and the train? Now it doesn't say that he has to do the bus in the morning and the train in the afternoon, so we want to find all the options that has the bus and the train. So here's bus and then train, so here's one option. And then if we go to train and bus, there's a second option. So two options make it work, so our probability would be 2/9, 2 out of 9. Okay, so it's a lot easier if you actually create the sample space than trying to think of all your options without that organized list right there. Okay, I'm going to go on to the next example. In the next example, you flip 3 fair coins. So I'm going to make my sample space. So heads or tails for the first one. In the second flip, we can have heads or tails. So I write that off of each of the first ones. And then the third flip, we can do heads or tails again. So I'm going to write heads or tails off of each of the previous results. So we count it up. We have 1, 2, 3, 4, 5, 6, 7, 8 different possibilities that we can get when we flip 3 coins. 2 times 2 times 2. That's how you get that. Okay, we want to know what is the probability that you get 2 tails and 1 head in any order. So we want to find 2 tails and 1 head. So in this first one, we can have this one head, tails, and then tails again. That's going to give us 2 tails and 1 head. That's the only option for that one, so we have 1 already. Over here we can do tails, heads, and then tails. That's 2 tails and a head. Or we can do tails, tails, and then the head. That would be 2 tails and a head right there. So I've circled 3 options. So my answer would be 3 out of the 8 total. So 3 eighths. So that's how you work with your compound events and trying to find those. Okay, I'm going to move on to the counting principle. So it's going to change gears a little bit. In the counting principle, this is used to just determine how many outcomes there are. So the sample space is great when the numbers are small and you want to see all the options. The counting principle is great when you're trying to figure out just the total number of options and you don't need to know what they all are. Usually use this when you have larger numbers. So this first example, we have John's putting on a shirt, pants, socks, and shoes, and we have all these numbers: 12 pairs of socks, 3 pairs of shoes, 5 pairs of pants, and 5 shirts. How many different outfits can he create? Well, if I were to make a list of this, it would be long because all you're going to do for the counting principle is multiply the amount of that you have for every option. So I'm going to do 12 times 3 times 5 times 5. So the amount that I have for each option, I just multiply those answers, and when you multiply those, you get 900. So John could have 900 different outfits. Definitely why we do not want to create a sample space for that. Okay, I'm going to move on to the next example. In our last example here, we're going to make breakfast. Here's our options. Now, it doesn't tell you how many there are, it just tells you what they are. So you have to do a little counting here. So for the egg option, we have 1, 2, 3, 4. For the meat option, we have 1, 2, 3, 4. And for the toast option, we have 3. So I'm going to multiply this number of choices, 4 times 3. And when I multiply those, I get 48. So we know that Max could create 48 different breakfast options with those items right there. Okay, so if you need to go back and watch anything, go ahead. Otherwise, have a wonderful day.